Hey guys, it's Emily, and today I'm explaining how to prove that the square root of 2 is an irrational number. So, a rational number is a number that can be expressed as an irreducible ratio of 2 integers. So, since now we know what a rational number is, we can then infer that an irrational number is a number that can't be expressed as an irreducible ratio of 2 integers. So, now that we know what rational numbers and irrational numbers are, I guess we should get on to explaining why the square root of 2 is an irrational number. The way we find it is proof by contradiction, which is when you prove something by showing that the opposite is false. So for a second here, let's just assume that the square root of 2 is a rational number. We just said that a rational number is a number that can be expressed by an irreducible ratio of 2 integers. So, let's just say it's P over Q equals square root 2. We also have to assume that P and Q, that this fraction can't be reduced anymore. We've fully narrowed it down. So, since we can't have any fractions in this, we should multiply both sides by Q. So, P over, that cancels out the Q and puts the other side of the problem as square root of 2 times Q. Now we should get rid of the square root. And we do that by squaring both sides of the problem. So we square the p and square this. That leaves us with p squared equal, then you multiply it out. Leaves us with p squared, and if you square the square root of 2, you end up with 2. And then, since we can't do anything with the q yet, since we don't know what amount q equals, we'll just leave it at that. Okay, so here's when we start to get a little closer to figuring out what p is. Any number multiplied by 2 is even, and any number multiplied by 2 is even. 2 and 2 is multiplied by 2, and that equals p squared. Any number multiplied by 2 is even, therefore p squared has to be even. If we know that, then that leads us to believe that p has to be even. If we can make p even, we can make p equal to s. Let's just say that. And so we'll just put that over there and continue with our problem. So if we want to rewrite this, it's 2s squared equals 2q squared. Now let's multiply this out. 4s squared equals 2q squared. You don't square the 2 because it's only the q that's being squared in this part of the problem. So now, if we want to get rid of both of these, we should put it over 2, because that would get rid of this. That would make, put it over 2. That would make 2s squared equals 1q squared, or 2s squared equals q squared. Like I said before, any number multiplied by 2 is even, therefore q is even, and p is even as well. But we already said that they were irreducible fractions, but if they're even, they have to be reducible. This goes against, this violates our initial assumption that 2 can be expressed as a ratio of 2 integers. Now, if you were to say, well, what if p and q did have a common denominator, then, you could always reduce it until there was no more common denominator and you'd be back where you started. Same problem, and you'd end up with the square root of 2 is an irrational number.